Now there are two locations where we can export results from, but for the FEA loads we can't export it from the post processor. We will export it from the main Adams View window. We select File Export and then select FEA loads. The format in this case is for a Nastran analysis, and we're going to specify the name Export FEA loads. Now this is simply the file name that it's going to use, and give it a txt extension, or let's rather give it a PDF extension. Now this is useful because then we can import it directly into Patran without needing to rename the file afterwards. Now since we may have saved a number of analyses in our model, we can set which analysis results we would like to export. I only have the last run's results available, and I'll be exporting those. If you did not create a flexible body, you're also able to export the loads of a rigid body. But since we have a flexible body in our model, we will be exporting our rockers flexible body results. And I'm going to add the load points to the load points table. Now what you will pick up from this, if I switch on the markers from my model, is that my structure or rocker part have 3 connections, and that is why when I picked this point, it immediately defined those locations for me. So it knows that I will need the forces at these locations due to the fact that this part was connected to other parts or Earth via these locations. So I don't need to enter these values myself, it is done for me. I will however need to work with these ID numbers as we go along. The next important step is to ask Adams for which time steps we would like to export these results. Now you can imagine if we're going to export the results for each and every time step, we're going to sit with an enormous set of data, and we don't want that, and we don't need that. We only want to look at results at specific times. So we want to basically find important points in time where we need to export the loads for, so that we can use each point in time as a specific load case on the FEA side. Now let's hold on to this for a moment and go back to our results. And we would probably find, if we go into our forces, so let's just fit the whole analysis over here, we can clearly see that this portion is where the structure is broken, and those are not really the results that we are interested in. We're more interested in the results close to the point before failure occurs. Now the important thing here is to note the relationship between the inputs and output loads. When we zoom out again, we'll see that these loads cycle, but they increase in value. And I'm going to pick these last few cycles as the ones where to extract our loads from. Now the load magnitudes are not as important as their relative values. And what I mean by that is that we're not only interested in these points where we have high load peaks, we're also interested in these points where the relationship of the values have changed. In other words, where this force dominated and this force dominated, in this scenario those forces are almost negligible and other forces or locations are important. Now I've simply extracted forces for the X and Y direction, since the Z direction in this particular case is the 2D or out of plane direction that we're not interested in. You will see the link, the rocker and the spring values over here. So it's important to pick a number of these locations as export points. We will get back to this point. The other way of looking at important points is to go to the durability plugin and run the hotspots table. And how this works is to again select our flexible body, select the run for which we're interested in the results, and then ask it to identify values of high stress in a reasonable range or radius of results, and report the points in time where we have exceedingly high stresses. And what we see from this is that we have a number of hotspots where there's high stresses in the system at specific timestamps. Now, unfortunately, in this case, if we go back to page 2, we will see that many of these load cases, like 14.97, is after the pin has broken, and those are not the results that we're interested in. So it doesn't help us to export the loads at those locations. We're more interested in these places in time where something else has occurred. Now, if we go back to 0.77 seconds, we'll actually see that was happening more or less at this location. So that means there's a point in time where we actually had a higher stress over here than at some of the other locations. Right, so using this information, we are going to define a number of timestamps for which to export the results. And just to repeat this again, I'm specifically interested in the number of these time slots where we have high peak values over there, maybe a location over here where we have high value over there but a zero value there, a point in time over here where the force directions change, maybe a force location over here where the green and black lines have zero values but the other files do not, etc., etc. So I'll export as many as these points as possible and simply make a note of the time value over here. So this is how we obtain our time values to export our results. So now that we've identified the locations using our file picker where we can read off the X values for specific locations on our graph, we're going to use that list when we export our results. So let's just go back to the main user interface where we can export those from. So I've selected my file type as FEA loads. I'm going to use an ASTRAN format. I've named the file ending with a .pdf file. That's just for convenience sake. I'm selecting my flexible body, clicking this point to give us the results at those 3 locations. And now I'm entering my list of times separated by commas where I want the results to be exported to. The units are reflected over here, and this is important because we have to use the exact same units on the FEA side to make sure that we are consistent. So I'll continue with that. And now we can actually look at the results in the file that was created. Now, if you have difficulty in finding the file that you've just exported, remember we named it Export FEA Loads. If you can't find the file, go to File, select Directory. This is the default location where any output will be saved. So in my case, my Adams folder. So this is very important to realize that you need to know where you've saved your results. So in this case, I will find my loads over here. So here's the file that I can now open up with a text editor and look at the results at those specific times. Now, the first thing that we will notice is the ID numbers of the flexible body. We see that over here, and those will be the ones, or the ID numbers of the node locations at those various points. Now, important thing to watch out for here is the fact that there is no results. Now, this is a very, very easy mistake to make. We have a file that was created, but there's no results. Now, what's the reason for that? Let me show you. Very important is that these actual times that I've exported are rounded off. The actual times at which data is available is actually a function of the resolution or the size of the time step that I've used. Now, I've used a script, and if I look at my script, I set those values in the script. And in this particular case, I had 1500 steps per second. Now, that gives me a specific frequency at which specific results are available. Now, if Adams does not have results at that exact time step, it won't export any results because it won't interpolate in between. But I can, however, force it to do that by specifying a tolerance. In other words, to find a time step close enough to this location within this resolution and export the results at that location. Now, if I go and look at my file, I should have results available. And indeed, now you can see I have a number of load cases listed for all the times that I've requested results for, and the file is already set to the file format that I will be using on the FEA side. So this is very useful, and also useful to note the node IDs. Now, these are quite important because we are going to need them in a moment's time. As you can see over here, we have the node IDs of the attachment points as well as the ID numbers of the Adams markers. So we have an Adams marker over here. This is marker 6, and the location of marker 6 we have is that value in X, that and Y, and Z and Z, and the same for the others. So here we have marker 5, and here we have marker 20, each of which we used in this particular case. Now, these locations are important because we need to create them on the FEA side as well to make sure that we have nodes at these exact locations to be able to conveniently interchange models that we've created on the FEA side. Now, this brings us to the end of the Adams portion of the process, where we have created our flexible bodies and extracted our loads from that. Now we're going to move on to the next section, where we're going to use these exported loads as load cases for topology optimization.